Hi, this is Kaylee, and today we're going to name some compounds. And to do this, there's actually three different types of compounds we're going to name: type 1, type 2, and type 3. And they're all based on where they are on the periodic table, what we do. Now, if you haven't already done so, this is always handy. This first column, I've marked a valence number. So this is +1, +2, +3, plus or minus 4, -3, -2, -1, 0. But that's handy to have because we'll need these later on to make sure all the compounds are balanced. For a type 1 compound, the first element is in the first two columns. The second element is to the right of this stair step that we have here. And we're going to use the proper name for this one, like potassium, lithium, calcium. But over here, we have to change the name. We can't just use oxygen or chlorine or iodine. We change it. We take the root word and we add IDE at the end. Now, what does that look like? Well, there's no easy rule, but basically it looks like this. Carbon becomes carbide, oxygen becomes oxide, phosphorus, phosphide, sulfur, sulfide, iodine, iodide. And so we try to take the root and then add IDE to the end, but for some of them, it's just taking an INE and change it to IDE. But for like oxygen, you almost get rid of the entire word. It's just oxide. So you need to know these things for us to work with this. So let's look at some type 1 compounds and name them. Starting off, we have got K2O. So K is potassium. So this would be potassium. And then that's oxygen, but we wouldn't call it oxygen, it would be called oxide. And that's it, potassium oxide. So again, take the name of the element for the first one, just write it out. And then for the second element, you want to use the root word and then IDE. So this one, calcium. And then it's fluorine, so now it'll be fluoride. So calcium fluoride. Lithium. And then P is actually phosphorus, so it'll be phosphide. BE, B's, where is that? Beryllium. Nitride. And this one, hydrogen. Chloride. Now, hydrogen chloride has a more common name. It's called hydrochloric acid. But that is when you start naming acids and bases, and there's little other things that goes along with that. But for this, naming it the style of type 1 is just hydrogen chloride. Now we also need to go the other way around. We've got to take the name and write the formula for it. And so that's when these valence numbers come in handy to make sure we've got the compound balanced. Lithium is in the first column, so it's +1. Sulfide is in this column, which is a -2. So if we do that, lithium is a +1, sulfide is a -2. We want these to add up to 0. So right now they don't. We have an extra -1. So we need 2 of these. So it will be Li2S, because we need 2 +1s to cancel that out. So that's the chemical formula. Sodium, that's Na. That's also in the first column, so it's a +1. Chlorine is over here. It's in the column that's I've got marked -1. So it is -1. So we don't have to do anything. These already add up to 0. So that's just NaCl, and that's your normal regular table salt. Magnesium, Mg, that's actually a +2. It's over here on the +2 column. And oxide is -2. It's over here underneath -2. And again, we don't really have to do anything with those. Just MgO. There's the chemical formula. Calcium chloride. Ca for calcium. It is a +2. Chloride, or chlorine, Cl, that is a -1. So we need another one to balance this out. So that's going to be CaCl2. Calcium again, so Ca, that's a +2. Nitride, which comes from nitrogen, it's a -3 because it is in this column here underneath -3. So we need to balance this out. So right now we have a -1, so we need another one of those. But when we do that, we end up having a +1. So now we need another one of these. These only show up in sets of -3. These only shows up in sets of +2. So again, now we got a total of -2. So one more of these. 6 here, -6. That's balanced. So we need 3 of those and 2 of those. So we get Ca3N2. And that is calcium nitride. Now those were all type 1 compounds. Type 2 compounds is when the first element is one of these transition metals. That's in this middle section all the way to your stair step. And those don't have a set valence number. They can be nearly anything. They can be a +1, +2, +3, maybe even a +4. It kind of depends. Now what we need to do though is we need a way to signify what the valence number is. And for that, we use Roman numerals. If it's a +1, it's got a Roman numeral 1, +2, Roman numeral 2, +3, Roman numeral 3, +4, Roman numeral 4. If it was a 5, it would be just a V. A 6 would be a VI. You wouldn't normally go that far. Usually the first 4 is plenty. Most of the time, it'd just be the first 2 or 3. But you need to know the Roman numeral because that's going to be the plus number for the metal. So how are we going to do this? All right. Now here's the problem. We've got iron. No problem, iron. Oxygen would now be oxide. Leave a space. But we need to know the valence number for iron. And we can get it because these are already balanced. So oxygen is a -2. And since we don't need but one iron to balance it out, that means iron has to be a +2. So we use the Roman numeral 2 to signify that. So it's iron 2 oxide. For this one, we have nickel. And then fluoride. Nickel fluoride. Now, fluorine is in that -1 column. And so there's 2 of them. So we get a total of -2. So this nickel has to be +2 to balance it out. So again, it'd be nickel 2 fluoride. Next one, we got copper. Your bracket for the Roman numeral. nitrogen, so it'll be nitride. Now, nitrogen is in the -3 column when I redid my periodic table with the valence numbers. So copper, there's just one of those to balance it out. So this one must be a +3 because it has to add up to 0. So this will be copper 3 nitride. Let's try this one. This one looks a little bit more difficult. So this one is cadmium. And then oxygen would be oxide. All right, now oxygen's -2, and we've got 3 of them. So that's a total of -6. So this has to be a total of +6, but there's 2 of them. So that means each one of these has to be a +3. So +6, -6, add up to 0. So this is cadmium 3 oxide. For this last one, we got chromium. Your brackets there. Iodide. So it's iodine. So you change it to iodide. Now, iodine is in the -1 column, and there's 2 of them. So to balance this out, chromium has to be a +2. This is chromium 2 oxide. You can have one that's got a Roman numeral 1. I didn't put one on here, but you can have that. So let's check when we go to writing the formula what it looks like. So we can go from the formula to the name. Now we got to go from the name to the formula. All right, so this one, we've got cobalt, CO, Roman numeral 2, so this is a +2. Oxide is a -2, so they balance, so it is COO. Copper, Cu, chlorine, Cl, and chlorine is a -1, so copper is a +1. Again, they balance because it adds up to 0, so it's just, let me write it better, CuCl. Titanium, Ti, bromine, Br. All right, now let's see. Bromine is in the -1 column. Titanium, that Roman numeral is 3, so it's a +3. So we need to balance this out. So we need a total of 3 over here, -3, +3, add up to 0. So this would be 1 titanium and 3 bromides. Manganese, so that's Mn, oxide, O. Oxygen is a -2. Let me write that better, -2. Manganese is a +3. Okay, we need to make sure they add up to 0. So if we get another of those, we still are not. That's +6, -6. So we need 2 of these and 3 of those. So there's your chemical formula, manganese oxide, or manganese 3 oxide. The 3 is not how many you have. It's what the valence number is. Don't get confused by that. The type 3 is actually the easiest ones to name, but you have to know your prefixes. So for type 3, the first element is actually over here to the right of the stair step. The second element is also over here to the right of the stair step. So both of them are over here. That complicates things because this is normally +1, +2, +3, plus or -4, -3, -2, -1 for the valence numbers. Since they're both over here, now this is going to be more like a +5, +6, +7. These have got to be the positive versions of themselves when they're the first element. So we have a different naming system for this that actually makes it easier. We don't have to worry about how many valence electrons we have in the valence number. It's really quite clever. But in order to do it, we need these prefixes. So, mono for 1, di or bi can both be, but it's usually di, is 2, tri 3, tetra 4, so like Tetris, get 4 blocks in a row, tetra, penta, hexa, hepta is 7, octa, nona, and deca for 10. So we have to use those prefixes. And the way it works is the first element only gets a prefix if there's more than one of them. The second element always gets a prefix. So let's see how that works. So this first one, we got carbon and oxygen. So it'd be carbon, because there's only one of them. Since there's one oxygen and we have to use a prefix, it's be mono oxide. So carbon monoxide. For this next one, we got carbon again. Since it's just one of them, we don't need a prefix, but this has to get a prefix, and there's 4 of them. So it's tetra, chloride. We still use the IDE endings. This one, nitrogen. It's by itself, so it doesn't need a prefix. Oxygen, since it's the second one, it has to have a prefix. Again, it's monoxide. Here we got nitrogen again, but this time there's 2 of them. So this one's going to be di-nitrogen. And there's 3 sulfurs, so it's going to be tri-sulfide. And for the last one, we've got 2 of these, so it's going to be diphosphorus. Trioxide, because there's 3 of them. Diphosphorus trioxide. So remember, the second element always gets a prefix. The first element only gets a prefix if there's more than one of them. If this had been 3, it'd be triphosphorus. Been 4, it'd been tetraphosphorus. So the prefix tells you how many atoms you have of each. That actually makes writing the chemical formula really easy. So let's start off with a very common one, carbon dioxide. So it literally tells you how many atoms. So no prefix, so that's 1. Dioxide, that means there's 2 oxygens, so it's CO2. Phosphorus trifluoride. So phosphorus, P, trifluoride. 3 fluorides. That's saying 1 phosphorus, 3 fluorides. Carbon, C, tetrabromide. So 4 bromides. Nitrogen dioxide, NO2, because di means 2. Dinitrogen pentaoxide, so that means 2 nitrogens, so N2. Pentaoxide means there's 5 oxygens, so it's O5. All right, so that's how you name type 1, type 2, and type 3 compounds. Remember, you figure them out by where the first element is. The first element is in the first 2 columns, then it's type 1. If the first element is a transition metal, it's a type 2. And if the first element is over here, it's a type 3. Now, can you use the naming system for either one of them? Pretty much, yeah. So, let's do a common one. H2O. And let's name it. Well, obviously it's water. That's the common one. But for a type 1 compound, the naming system would just be hydrogen oxide. If we're naming this in the type 2 style, That's a -2, so these are going to be +1s. So that would be a hydrogen. Roman numeral 1, oxide. If we're naming it by the type 3 style, that'll be dihydrogen, monoxide. So dihydrogen monoxide. But commonly, they're named type 1, type 2, and type 3 by the location of that first element. Well, hopefully this helped, and tune in again for some more science. Bye.